I think that's it. I hope. We'll see. I never know entirely if we're live or not, which I think is a problem everybody has, just because of the delay that YouTube naturally has. So maybe you saw me drink some water, maybe you didn't. I don't know. Anyway, so we had some comments on the last video when I announced the stream, and it seems that the most likes were on the comment to do a missile command that was by Charles Anderson. So I think we'll go forward with that, but we're going to try to do some sort of something fun with it, a little different. Maybe throw pizzas instead of missiles, or do some other. I don't know exactly what. Maybe you can help me decide what we're going to do as a twist for the game. But before we really get started, I've got some announcements for Growling Pigeon as a company. So I've been trying to figure out hats and shirts and stuff. So this is the Growling Pigeon Studio hat, and it needs some work. It needs to be updated. The stitching is really good, but the design needs to be fixed a little bit before it's something that people might want. And so that's the question. Is this something that you do want, or am I just deluding myself? Because I'm happy to put on a shirt or anything else myself, but I'm not much of a hat guy. I kind of look dumb when I wear hats. I just don't want to mess up my hair. In addition to a little bit of a foray into merchandise, got a website up that you can see here, Growling Pigeon Studio. You just go to growlingpigeon.com. You'll be able to see this website here. I've got a couple of games linked that I've made. I've got Pigeon Scratch, which is, I think, a favorite, and Fulfillment, which is currently $2, but that's going to be reduced to free soon. I don't know exactly when, but I want to make it free. I just don't know when. Maybe after I get a surge of popularity. Yeah, I'll take everybody's money first, and then I'll make it free. All right, well, I think that's it for the updates on what's going on. So, Missile Command, that's what we're doing. That was Charles Anderson's idea, and he got 2 likes. He probably just liked his own comment twice. He probably got like a second account. It's like, there you go. He was watching the other comment to decide how many accounts he had to make. I'm just kidding. I trust that people are playing fair. All right. So, Missile Command. Basic idea is we've got we have a city that we're trying to protect, or cities that we're trying to protect from nuclear missiles. These nuclear missiles are coming from the sky, from some unknown entity, whether that's aliens or another country, and we're trying to explode them in the sky before they hit the cities. We have a couple of embankments that we can use for protection, and we have a little turret that goes side to side. That's the basic idea. As I'm doing this, though, try to think up some twist that we can do for this game, so it's not purely Missile Command, but it's something just a little bit different. All right, so we've got to have a player first and foremost. Let's create a 2D object, just a square for now, white boxing it, and let's call him the player and move him down so that when we play, he's at the bottom of the screen. Oh, and by the way, the background needs to be black. Obviously, Missile Command has a black background. Though, do we really want to do that, or do we want to do something a little bit more happy and cheery? Maybe like a blue background with like clouds. That could be fun. Yeah, let's do that. Charles says, "Stay paranoid, my friend." I am, and I will. They're coming to get me, don't you know? All right. So, basic idea, we're going to have some input, and I'm not going to do anything fancy with our input here, just a basic input. So we need to keep our state because we're doing our updates on the fixed update, right? So, private. We don't really have movement up and down in missile command. We just go side to side. So, I think if we just had a private float, which is movement, and so negative is left, positive is right, sort of thing. And you know, of course, this starts at 0. That's start. We don't really need anything on start right now. So this stop movement will be updated by some key input. But every frame, we're going to assume that the input is 0. So we're just going to zero it out again and again. And then we're going to do some logic. So if input get key and key code, well, let's do WASD. So key code A, that would be left. And this dot movement. And you know what? It doesn't really need to be a float. It can be an int. That way we're not going to get any weird floating point arithmetic problems. Because floating points are weird. And sometimes you think you're doing something really basic in your math, but you end up getting these numbers that have like thousands of decimal places. Okay, in a float you don't have thousands of decimal places, but hopefully you get the idea. Alright, input, get key, key code D. So what I'm doing here is the idea is if you hold down the A and the D button at the same time, then you shouldn't be moving right or left. You should stay put. And this will do that. So if I'm pressing A, then your movement will say, hey, I'm going left, so minus equals 1. So that's negative 1, right? But if you're holding down D, then it will plus equals 1. So negative 1 plus 1 is 0, and so there'll be a 0 movement. So this will enforce a little bit of security that way. I always hate it when I hold down 2 keys in a game, and this happened a lot in old games. Where you'd hold down 2 keys, and one of them would be more important than the other, and would get precedence. That always kind of sucked. All right. Fixed update is when we're going to do our actual movement. So private fixed update. And this is the physics step. This transform position. So we're going to get kind of our current X position. So this will be a float. Come on, if I can type. Float X equals this transform position dot X. And, you know, it's kind of sucky because you can't just pull this out of the property. So position is a property, and X, Y, and Z values are all properties. And the transform is a property. So you can't basically make updates on these structs the way that you would with objects. So I have to recreate a new vector every time, which is okay, but it is a little bit silly, a little bit annoying. I suppose, well, I don't think I can do a plus equals. I've always just done it this way, and I think the reason is that I can't do a plus equals on vector 3s that are on the transform. But be it as it may, actually, since we're only moving the x, I believe transform has a translate method. Yeah. And you can do x, y, and z values independently. Yeah, so perfect. So I don't need to worry about any of that. I'm just an idiot. It happens. Sometimes I'm just a moron. Alright, so we're not going to move x or y, or sorry, z or y. We're just going to move on the x-axis. And this obviously needs to be multiplied by time, fixed delta time. And let's lower this so that everything fits on the same page, so that everybody can follow along. Okay. Well, let's check this out in Unity. Attach that script to the player, and let's run. Okay, that's A held down and D held down. Of course, I can't move up or down. And if I hold A and D down at the same time, there is no movement. Fantastic. So now we also need to shoot. We need to be able to fire projectiles and do all that. And that'd probably be best with a mouse click. So let's try to figure that out. Let's try to get our mouse position. And we need a reference to the main camera in order to use this mouse position in any meaningful way. The camera main, or our camera. There we go. And this should be a serialized field so that we can apply it in Unity. Okay. This, our camera. Screen point to array. So what this will do is generate a three-dimensional ray for us that we can then raycast against any objects. What we might want to do is have a background object. Actually, this ray should have a Z and Y origin, since we're using a well, every camera view has what's called a frustum, and the beginning of the frustum is still a two-dimensional plane. So we should be able to plug into that two-dimensional plane, especially since it's a 2D camera, which means that that plane is the size of the viewport. So I don't think I need to use the raycast. I think I can just get the XY position, or yeah, the XY position from this, rather than having to do any physics calculations. So what we'll do is capture the ray, and then we'll log. So debug log. And we want the X and Y positions, and make sure that they make sense, right? So ray origin X and ray origin Y. Okay. back here in Unity, we're going to look at the console. And what is this? 1, 2, 3, 4, 5. Up. 1, 2, 3, 4, 5, 6, 7, 8. So we're expecting about 8.5 right and left, and 5 up and down. So from -5 to +5, and -8.5 to +8.5. And I'm getting an error. Oh, that's because we haven't assigned the camera yet. So there's the camera. Here we are. So if I move the camera over here, or the mouse over here, I don't know if you can see those numbers scrolling by at all, but I'm getting an 8.4 and about 0 there. And if I come all the way up here, I'm getting about an 8.5 and a 4.9. So that's what we expected. So these are the correct mouse values. Very cool. So now we need to be able to detect a player input and shoot a laser in that direction. And to do that, first let's create a target object so we know that we're making that, we're actually hitting that location correctly and moving things properly. So let's create another 2D object, and this will be a circle. This is our target. Color, let's make it red so it stands out real well. And yeah, back in our script, we'll need a reference to that target. And so now we are no longer going to log out. We're not going to get the ray every frame because that's just not very efficient. So if input get mouse button down. I think 0 is left. I'm not entirely sure. We should be able to get that screen point array, and then let's move our target there. So this dot target transform position equals new vector 3. This time we can't do a relative transform or translate because we don't know where its original position was. We don't want to have to do math and all that. So we're just going to set it directly. So x is going to be ray dot origin. And you know what? This ray, we can actually have this be world position. And let's just get origin right off of it anyway. That way we don't have to keep getting origin every time. So world position dot x. And then z should always be whatever it originally was. So z will equal s dot target transform position dot z. That way it doesn't start going forward or backward over time, but stays in line with where it originally was, which I think is 0. And we can enforce that or whatever, but I want to be able to make it dynamic. So if I set it in the scene, then it will stay where it was and not move around. All right, back to Unity. And our player needs a reference to our target. Go. And if I run and click, there we go. Perfect, our target. If I hold down the mouse button and I move around, it's not following the mouse. It's just staying there. Very good. So now we need some sort of laser. I'm not entirely remember exactly how missile command looked. So let's look that up. Maybe we want a GIF so we can see the movement. These may not have movement in them or motion. I thought the player missile was kind of slow. Maybe these have GIFs. Missile command recharged for mobile platforms, really. Well, free advertising. You can go and download that now. Alright, well, I'm not getting any help with that, so I'm just going to assume that it was a slow missile. And that missile leaves a trail behind it, right? And I think the trail goes away after it explodes. Or does it go away after some time? We can do either one. It doesn't really matter. Let's just create a missile. Well, player missile. And these are going to have to be pooled. That way we're not constantly loading them into memory and dumping them. It may not be that important because this is just kind of a mock-up real fast, so we may not actually have to worry about that. So let's create a new folder for create a folder for projectiles. And that's where our scripts will go. We also need a folder for our prefabs. So we'll be copying from the prefab folder whenever we create a new missile. Player missile. And it will need some details. Well, first of all, it needs a sprite. Sprite renderer. And let's choose the knob. And since it came from us, let's make it green because we're the good guys. I hope that's the right size. I don't know how zoomed in I am. Oh, that's tiny. That's not good. Yeah. Let's make that much larger. Bring it back out. And let's actually create empty underneath this. And this is our sprite. That way we can scale the sprite independently of... Well, actually, is that too small? Because we don't really want the player missile to take up that much space. So maybe we don't want it all that much bigger. Either way, it's good practice to move this lower anyway. So let's remove that component, add the sprite renderer here, do the same thing, knob, and color is green. Okay. As far as a particle effect behind it, what we could do a particle system, or we can do our own objects. And I'll leave that up to the chat, what you guys decide. Should we do a particle system and kind of go through that process, or should we just do our own objects that we can kind of control for the tails of these projectiles? Okay, so player missile needs to go toward the target. So start at the player and go to the target. Now we don't need that in the scene anymore. We do need a script for him. So let's come in here. I don't see that folder. Make it in Unity. Hello, create C# script. I don't know why it didn't work that time. So, player projectile. Okay, and this is in assets dot scripts dot projectiles. And it's really good practice to make sure that your namespaces are separated. Otherwise, you get a whole bunch of files all in the same namespace and it starts getting cluttered. So on start, what we'll do is search for and find the target, which means that we'll need a target object or a target script. Target controller. And this will be a mono behavior, and it will be completely empty. Okay. And this is just so that we can attach it to our target and have the player projectile find it very quickly. So this dot target equals find object of type target controller, and get the game object off of that. Game object target. Do we really want the target, or do we want, because if the target moves, then obviously the aiming will change, and so we don't really want an object reference. We want a reference that's not going to change. Let's actually go with vector 3. And so this is game object transform dot position. So that gives us our vector 3, and let's lower that so that everybody can follow along. All right. And of course, we have a start position as well, and we just want to be able to move toward the target position. And if we got the length, then we could determine, or the distance between the start and the target, then we can use a lerp, which I think is probably going to be the safest way to go around this. It'll take less calculation, and it'll be, faster to calculate, but it will also, we won't have to fiddle around with angles and stuff, which is always just annoying. So what we'll do is keep our start position, and so our this dot start position equals, and we'll find the player, find object of type player controller. Yep. And the same thing, this we're going to get the game object off of it, its transform, and its position. The player controller needs to be brought in because it's in a different namespace. Okay. So then we find the distance. So this dot distance equals vector 3 distance between this dot target and this dot start position. So this will allow all of our projectiles to travel at a steady speed, whether their target is far away or really close, and still be able to use lerp. So we're going to be able to change the rate at which this object changes position based on all of based on this distance. We're not going to do that during update. We're going to do that during fixed update. So private void fixed update. Also, we're going to put ourselves at the starting position on start. So this dot transform dot position equals this dot start position. Sound good? Okay, good. So, what is the equation that we really need to be doing? Let's think this through for a second. So if it's farther away, then it needs to lerp a little bit slower. That way it takes longer to get there because it's farther away. So what we can do is divide by distance, because distance should never be 0, right? Unless you're clicking directly on the player. We can guarantee that it will never be 0 by saying, you know, if the distance is 0, then just destroy this object. We can also guarantee it by not allowing the player to click below a certain threshold. And a combination of the two would probably be a good idea. But we'll make sure that the threshold is taken care of by the player object. So as long as it's not 0, which it won't be, we're going to make sure of that. Then we can divide our lerp by the distance, and that will make a higher distance travel slower. So this dot transform position equals vector 3 dot lerp. And so we're going from this dot start position. We're traveling to this dot target. We're traveling at a rate of, we kind of want a distance of, let's say a distance of 1 to take 1 second. That would be a pretty slow movement. I don't know if Missile Command was that slow. And we can alter this as we need to. What we'll do is the speed, so we're going to say 1, multiplied by time dot fixed delta time. All of this divided by distance. We actually need to add this to some value. So this dot lerp value plus equals this. So that's our addition there. And so this will be this dot lerp value. We need to engage some sort of destruction when we get to our end, our target position. So when we get to the target position, we explode, and that explosion expands, and any monster missiles that are in that radius will also explode and have an explosion radius, and I think it'll just create the same object for both of those, but we'll need some object that does that, and we can handle that as we move forward. But for now, we want to make sure that lerp value never gets greater than 1. So if this dot lerp value is greater than 1, and this dot lerp value equals 1, we're going to be able to change the position, and then we will explode. Dot explode, which will be fun. So we need to track our lerp value, which will be 0 to start with. And then explode. Right now, we're just going to destroy this object, and then later on, we'll create our explosion radius. Alright, so we'll just delete this current object type of thing. For the player controller, we need to spawn one of these player objects, or these player projectiles. So we need another reference. And this will be our projectile prefab. And this dot, well, instantiate. This dot player prefab. Or projectile prefab, sorry. Alright, so this will just create one, and it will, since we already added all the code to its start method, it will find the target, it will find the player, and everything else without having to explicitly load those values in. So this should work beautifully. I think that's all we need. So things to add. Our target needs the target script. So target controller, there you go. Our player needs a reference to our player missile prefab. That way it can keep creating them. Alright, and let's see how this plays. So if I click here, we should get a projectile was created. It's not doing anything. Yeah, it's just at position 0, 0, 0. Oh, that's because we never added the script to it. Oh man, there's so much to do. Player projectile controller. All right, so now if I click, it starts at the player position, but I don't see it moving, and indeed, it's not updating its position at all. So I wonder why not. Let's go back in. Player projectile. So this dot lerp value, we're adding 1 multiplied by a fixed delta time divided by this distance. Now, distance isn't a huge number. I mean, at most, it's going to be 17, And, well, it's going to be the Pythagorean theorem. It's going to be the hypotenuse of a triangle with legs of 17 and 10, which really is not that far. It's probably close to like 21 or so. Maximum, absolute maximum bound of like 25. So that's not a huge number. So I wonder why this is not doing anything. Vector 3 lerp. That's going to give us a vector 3. This dot lerp value. If the value is greater than 1, then set it to 1. Oh, we explode no matter what. That's what's happening. If this dot lerp value is greater than or equal to 1, then we explode. Now that doesn't explain why the object didn't just disappear. So I think it's this dot game object that we need to destroy. Because I think it just detached the script from the object, not destroy the object itself. Okay, so let's try that out. Excellent. I don't know if you can see that real well. Zoom in a little bit. I'll click here, and you should be able to see that green coming over and hit the target. So if I create a bunch of targets, then exactly we get 4 of those projectiles. Look at that. Oh, that's beautiful. All right, bring the scale back. Maybe we should make the background black just so that it's easier to see everything. So, main camera, let's make that all black and lonely. And let me know in the chat if you can see the green projectiles on the black background. I want to make sure that you guys can see that. And they're all traveling at the same speed. So if I put one here and one out here, obviously the one that was closer hits its target first. Beautiful. You know, maybe I should just make art and do this instead. Well, I'm waiting for you guys to tell me if you can see the green projectiles. Alright, so we need to hide the target. Target does not need to be visible. So let's get rid of the sprite renderer. Now the object is still there, but it's not visible, as you can see. And of course, as we move the player, he'll throw projectiles from a different location. And this should create like some sort of spiral. That's so cool. They all go to the same spot, but in like a weird spiral way. Okay. Cool, cool. Alright, so we said that we need to make some sort of radius. So when the projectile explodes, it needs to, you know, create some sort of object that gets bigger. So let's create another 2D circle. And set it at 0, 0. That's fine. This will be explosion. The color needs to be, oh, let's make it like a kind of an orange, a fiery orange. I think that's good. And it will need a circle collider. This will be a trigger. So other missiles that get hit by it will explode. And we can test that later by having a whole bunch of missiles just falling from the sky and see if explosions cause them to explode or not. So we need a script for this explosion. So let's go back into Visual Studio, create a new folder. Call this probably just explosions. Explosion controller. Behavior does not need a capital O there. Okay. So what this will do is start small and just get bigger over time. And let's say that it takes a second to get to its full size. Full size, we'll say, is a radius of... what's a good radius? Radius of 1? Radius of 2? Let's try a radius of 2. So, private float max radius equals 2. Private float start radius 0.5. Actually, we're just going to do this on fixed update. It'll just keep sizing over time, which means that we need to keep track of our time. Private float time 0f. Okay. So this transform dot scale and this is of course a vector 3, so we're just going to assign the current radius to all of them. So current radius and this is a float. You know what? We can just do a multiplication here. We can do vector 3 dot 1. So this is 1 where all of the vector 3, not vector 2. So all the values are equal to 1. And then we multiply that by current radius. And current radius is going to be math f dot lerp start radius max radius and this dot time. Lower all that so we can see everything. Okay. I think that'll do it. And then when it gets to our maximum radius, so obviously current radius can't be more than 1. Same thing as the missile moving, it can't be more than 1. So if current radius is greater than 1, sorry, not current radius, it's not time. There we go. And then the same sort of thing. We need to destroy this. So if this dot time is greater than or equal to 1, and this time, or sorry, destroy this game object. So now every projectile is going to need some sort of reference to our explosion object. We go to our player projectile. We'll instantiate this dot explosion prefab, and we'll assign the position. So this dot transform dot position and quaternion identity. And you don't need to worry about what quaternions are, really. They basically express rotation of a three-dimensional object in three-dimensional space using really weird math. Don't need to worry about it. They're easy to compute, really fast. We're just using an identity, which means don't rotate at all. We need an explosion prefab on projectiles. All right, explosion prefab. Sounds like fun. That means that we need to create such a prefab in Unity. That's basically what we've done. So, I mean, we haven't made it a prefab yet, but let's add the explosion controller. Turn it into a prefab. Explosion. Delete it. And then the player missile needs a reference to explosion. All right, let's test that out. See if we get an explosion that kind of gets bigger and then disappears. So we'll target over there. And not quite. It tried. I don't think we're updating time on that. So explosion controller. Yeah, we're not updating time at all. So this dot time. Time dot fixed delta time. There we are. And then it should die. Now I saw it start off really big as well, and that's going to disrupt the gameplay. So on start, we need to make sure that it is scaled to 0. Let's just copy this. Make sure it's vector 3.0. That way it's not taking up any space. Okay. Now let's see what happens. Oh, beautiful. Kaboom. Huh. Oh, that'll be fun. Let's see a whole bunch of them at once. That's like fireworks on the 4th of July. Very cool. All right, so next thing, we need to add some rigid bodies, and rigid bodies are affected by gravity. So let's turn off gravity. We'll go to our project settings, and in project settings, go to Physics 2D, and there is a gravity property. If I can find it. I don't know why I can't. Here it is, all the way at the top. I'm such an idiot. All right, so 0, 0. That way we have 0 gravity. Okay. That should be updated. Now, for every projectile, we want to be able to detect that there's an explosion happening nearby, see if we're in that explosion, and if so, then we need to explode ourselves. What we'll do is private void on trigger enter 2D. And we know that explosions are going to have the explosion controller script on them, so we can just check for that on this collision enter. So if collision, get the game object, get component, type of, or sorry, not type of, we just need explosion controller. So if that is some object, so if that exists, basically, then we know that it's an explosion, and then this dot destroy, or explode, or whatever it's called. I don't have an explode method on this, so let's create one. I'm putting this on the explosion controller. I don't know, what am I doing? Remove all this. This should not be on the explosion controller. We don't want explosions to explode themselves. That would be weird. So, player projectile, here we are. And this does have an explode method, which we can just call. Okay, but that means, of course, that we need to have a rigid body attached to be able to detect. Rigid body 2D. And this should be kinematic. Okay. We also need to have a circle collider on it. Collider 2D. And let's make sure that that's properly sized. Beautiful. So as that scales, well, actually, it's not going to scale because it's not the explosion, so we don't need to worry about that. So if I launch a missile here and then another missile out here, this one should get caught up. The first one, yeah! There you go. So they explode each other. So if I have a whole chain... Very nice. That's beautiful. Okay, so now we can create enemy missiles. And these will be falling from the sky. I think they're just going to basically inherit from this. So let's bring this guy out. Let's unbox it. Where's the box? Prefab, there we go. Unpack. Okay. So this will be our monster or enemy missile. Okay. And the sprite, we're going to make that an evil red. Ooh, it's just so evil. We're going to add a little bit of purple into it because it's just so evil. And for right now, we'll just add a couple. We'll just kind of place them somewhat randomly up here. Of course, they're not going to fall. Oh, they all have that same script. That's right. So let's delete all these. That was awkward, but that makes sense. They all have the same player projectile script, and so they started from the player and went to 000 because that's where the target starts at. Is 000. Okay, so that means it needs its own script. Projectiles. Add new item, and this is enemy projectile. And let's copy basically everything from the player projectile. And then select what we do and don't want to keep. Okay, and of course we need Unity engine to be brought in. Explosion controller, we need that. Which means, of course, that this prefab will need a reference to the explosion prefab. We don't need to know. So we don't have the same start position and everything else. I don't know if we want to target the player. I don't think so. Let's not. I don't know how insert got hit. I hate it when that happens. All right. Distance we will need, so we'll need a target and we'll need a start position. That will need to be figured out. I think what it ought to do is target one of a random town. So we'll want to create some towns. Randomly choose one. That'll be our target, and then it'll go down from wherever it started. Right now, let's have the player controller be its target. And wherever it currently is its start position. I think that'll be good for right now, and then we can update that as we build towns that need to be destroyed by the enemy, and that we need to protect as the good citizens of Protectopia. So I think that'll do it. I don't think there's anything else that's actually all that important to do on that right now. Okay, So we have the one enemy missile. It needs the new script. So replace that with enemy projectile. Okay, put that there. Remove player script, or player projectile script. And this should be its own prefab as well. Okay. So now it should launch at the player. And if I launch my own missile at it, let's see if I can hit it. Oh no! And of course it doesn't have a link to the explosion prefab. So we need to make sure that it does. There you are. Okay, so let's try it again. This is already kind of fun. Oh, beautiful. All right, and obviously that can chain and all sorts of stuff. Let's see, what time is it? It's 6:09, and we wanted to stay within about 2 hours. So we have enough time to do towns and embankments and everything? I don't think so. We do want to generate these missiles, these enemy missiles, randomly. We also want to limit how many projectiles the player can produce at a time. So I think there should be a cooldown time for the player. You can only create one projectile per half a second, maybe. And then as far as the enemy projectiles, would it be too overwhelming to have two every half a second? If we can only launch one every half a second, is that too often? I don't think so. We'll make those parameters available inside of Unity. That way we can kind of alter them based on what is overwhelming and what's not. So let's create some enemy, an enemy spawner. So, new folder. Spawners, add, new item. Enemy spawner. Okay. And we will need a height, so private float. Well, actually, the height should just come off of its own position, so we'll do that. But width, it needs to be able to generate from negative to positive. I think we said 8.5. We're going to start with 8.5, and we can alter that if we need to. Private float frequency, and we'll say that we can generate 4 every second. We'll serialize this field as well so that we can edit in Unity and get kind of the right feel for us. And of course we need our prefab. So missile prefab. Private float cooldown. And we'll just create a missile right at the beginning. So every time it gets to 0, it'll have to go back up and come back down to 0, and it will launch another missile at some random position. Okay. So private update. This dot cooldown subtract equals time dot delta time. If this dot cooldown is less than or equal to 0, then this dot launch missile. Well, we'll launch a missile. The player will worry about what that method says later. We'll also need to reset. So this dot reset cooldown. So that'll do its own thing. And I think that's all we need in the update method. So private void launch missile. And what we'll do is instantiate this dot missile prefab. So we're going to need to figure out what its start position is going to be. It's y. So float y equals this dot transform. Hello. Position y. So wherever we place this spawner in the world is where we're going to be kind of spawning from. Is the idea. Transform dot position dot x, and then we're going to add some randomness. So plus random within a range. So our minimum is this dot width, this dot width. So this is negative and positive width. Oh, that's deprecated, really. Use just range instead. Okay. Fair enough. Okay. So that'll launch a missile. We've given it a position. Oh no, we haven't given it a position. We've only calculated the x and y. So missile dot transform dot position equals new vector 3 so its x will equal x, its y will equal y, and its z will be whatever it originally was. So missile dot transform dot position z. Then we also need a reset cooldown. So private void reset cooldown. This dot cooldown equal dot frequency 1 divided by whatever the frequency is. Okay, let's put that into the game. So Create empty. This will be our enemy spawner. Add that script. Move it up here. And it needs to know what the prefab is. Enemy missile prefab. And let's see what this looks like. Oh no, there's so many. Ah. No. There's too many. I can't rely on chain reactions. Oh, shoot. Oh, man, that looks freaking sweet, though, doesn't it? And, of course, if I move the player, then they should start targeting where the player is. Oh, look at that. They're defeating themselves. Oh, man. That's fun to watch, actually. It's kind of a fun little simulation. All right. What time is it? 6:19? Okay. We have about 40 minutes remaining. I don't feel like we can really do anything all that complicated from here forward. Obviously, that slowed down the frequency a lot, so maybe 0.5. Because that was way too many. So now it should be once every 2 seconds or so. And this is something that I can handle just a little bit more. Okay. So obviously we need some villages. How are we going to do that? We create an image. Do that. So this is a program called Sprite. I'll put that up there so you guys can see it. It's not hidden by my ugly mug. All right, so a village, we'll just kind of represent with like a little hut. So if I do something kind of like this, do something kind of strong baddie, or not strong bad, but you know, like what the villagers were living in Trogdor, the Burninator, if you remember that. I think that's what we're kind of going for. It doesn't need to be anything beautiful. I think that is probably sufficient. Maybe a darker roof. No. And maybe a door on the front. We can fill in. Yeah. There's our little village. So we'll export that. We need to put it somewhere, so not in documents. Let's see. Top prototypes, missile command, assets. And we'll just put it here. Okay. So now in assets we should have a village. So let's just move that in. That's a bit small. So pixels per unit, let's call that 50. Yeah, that's a bit better. Player should be above villages. We'll put one there. Put one there. One there. One there. And our spawner, I guess, should be the one that tells the missiles where to target. So in the spawner, let's create an array. Transform, array of transforms, and this will be our villages. So we do that, we'll need to load into the missile its coordinates. So missile controller equals missile get component enemy projectile. Okay, and the missile controller will load the value. So missile controller set target, and this will be some randomly chosen village. So this dot villages random range should be an int. We'll round to int, so mathf round to int. A random range. This is getting complicated, but basically what we're trying to do is select a random village, and the range should be from 0 to this dot villages dot length. And instead of round int, we should floor to int. That way we don't go above the length of the villages array. So set target, we need to create that method. And so then this target and distance and everything else will be calculated in set target. So target will be transform position. I think that'll work. So now we need to give our spawner all of our villages. So let's select all of them. So village 1 through 4. Go. Let's see what that looks like. Alright, looks like they're targeting those villages perfectly. Oh, this is beautiful. So much death and mayhem. Oh, fun. Alright. So the enemy missiles shouldn't explode when they reach their destination. They should... Well, maybe they should. But if they reach their destination, then they also perform damage to that that village. That village should disappear. So what's the best way to do this? I think on all the villages, we're going to add a box collider 2D, which is trigger. I think you know where I'm going with this, and we're going to add a script to it. So add villages. We'll just create kind of a empty mono behavior again. Village controller. Okay. And then with the enemy projectile, what it will do is if it's a village, so if collision game object get component village controller is not null, then what we'll do is collision dot game object dot set active. We'll make it inactive, so it will disappear, but it will still be in the world. That way we don't get null references and all kinds of weird things, right? And then we need to make this go away, so destroy this dot game object. So then all these villages also need the village controller. Script. And let's see what that does. Here comes some enemy projectiles, and they hit the village, and the village disappears. There's no explosion. Maybe there should be an explosion. I kind of miss those now. So we'll just explode. Okay. Of course, now we can try to defend our villages. Didn't do a great job. And we need a village counter of some sort. Put it on the main camera. Well, we can actually put it on any object that we want. Let's create game flow, and we'll add score controller. So on the score controller, which is a model behavior, we need a score, obviously, so public int score which starts at 0, and a public int villages set. And this starts out as 4 because there's 4 villages. We'll need to if the villages ever gets to 0 or less, then we'll have a game over screen that shows up that says, hey, you lose. We'll also yeah, we don't need to worry about deactivating anything. We're just kind of going quickly because we only have less than half an hour. So we will need some reference to private game object, game over UI. And that should be lowercase on the game over. Okay. If this dot villages is less than or equal to 0, then this dot game over UI set active to true. So this will tell us that our game is over and that we lose because all of our villages got destroyed. We'll also want to have a score element that will show. So let's come into enemy projectile because it's the one that controls all this. So if it's currently active, game object all I see is active, and I'm told that that's deprecated. Maybe we need some boolean on the script itself. So get component village controller is alive. Then we'll do all this. So we'll worry about setting it as inactive and exploding and all that stuff. But this will also set or increase the score. So I'll find object of type, and we want our score controller. And reduce the villages by 1. of course, we'll set alive to false. All right. Then we'll need some sort of value. With this, we will increase the score when it explodes. Score will increase. What's going on? Let's see. That's happy. Why are you not happy? That's because it's a private set. We don't want that. Okay. Now it's happy. All right, so we just need to draw the score. We need to draw a game over. I think we'll be done. UI. We'll need a text. This is score. Canvas. I think all that's good. Scale the screen size. Yep. So on. Okay. So score, we'll bring up here. The text color should be a little bit brighter than that. That's pretty dark. Make it a pure white, because all those old games had white text. And font size, let's bring that up significantly. We need to make this bigger. There we go. So score equals 0. And then we need another panel. This will be game over. And it needs its own text, which again will make really big. I think that'll do, right? Does that look good? I think so. All right, now on our main camera, we can add our score controller. Game over UI is that. And you know what? We need to update this text as well. Let's go in and make sure that happens. We need a reference to the text. text. This dot score text dot text equals a new string that says score is whatever this dot score is. Okay. Unity. It'll need a reference to our score object. I think everything is plugged in and ready to go now. We'll find out if we get a bug. So, well, okay, obviously game over needs to not be visible at the beginning. And it should not be transparent. There we go. It should not start off active. Okay, so let's play the game. So I'll shoot at him. No, get back over here. You need to die. Ah, no, I'm losing already. This is too hard. Ah, game over. All right, I don't think I got any score at all. Let's try to get something. So we'll launch missile at that. Hopefully something works here. Uh-oh. Uh-oh. I might have caused a crash. Well, we killed Unity. Too many explosions going on at once since they were constantly causing problems. Oops. Oh well. Let's try that again. Those enemy missiles are too fast, and my missiles are too slow. I think we need to fix that. All right, let's open this back up. Missile command. Try to fix that speed. Apparently I'm being asked what I want for dinner. And I need to ask for steak. I already had dinner, so don't worry about me. I went and fed myself. Okay. So what we were doing, right. Our enemy projectiles are too fast, and we are too slow. So let's fix that. Let's go into the enemy projectile. And to make it slower, alert value by distance. We can slow it down by making this 0.75. Okay. And then the player projectile will speed up by making that same value higher. So let's make that a 2. Make that a whole lot faster. Then as far as the player himself, oh, where was the movement? Okay. Let's multiply this by 5. Make him just a little bit faster, or a lot of it faster, moving across the screen. All right. Now let's play. That should go a lot faster. Yeah, the enemy projectiles are much slower now. More manageable. And now I'm actually getting a score, so that we can see that that's increasing. I've already lost 2 villages, though, so this is horrendously bad. I am not good at this game, apparently. Anyway, this is kind of fun. Game over. Well, fun. This has been a great experience. I've never made a missile command before, and I really suck at it, just like I do in the arcades. I suck at missile commands so bad. But what I want to do is, with this code and the previous live stream, I'm going to put that out on GitHub. That way you can download and play the games yourself. You can look at the code, you can change whatever you want, make it play better. You can make your own game out of it, sell it, make money. I don't care, as long as you're having fun. But I want to do that, so look out for that as an announcement, and I'll post that on Facebook, and I'll make a YouTube video as well. But how do you guys feel about Thursday? Is Thursday a bad day for live streams? Or is Saturday a better day? And while you're answering that, I'll tell you a little story about yesterday. So, I don't know, after naming the studio Growling Pigeon, I just kind of started getting this little bit of a fascination about pigeons. I guess once you name yourself something, you start caring about it a little bit. So yesterday, I saw what I thought was a female pigeon in the backyard, and I thought it was super friendly because I was working on some furniture and some patio furniture, and it didn't run away or fly away or anything like that. It just kind of wandered around back and forth. I thought it was just friendly. It liked human beings. But apparently it had broken its wing. So Stephanie got home and took a look at it. Decided that it was really sick. And so then we spent the rest of the evening, somewhere around 2.5, maybe 3 hours, we were calling around trying to find a place that will take this bird as like some sort of wild animal refuge. Finally found a place up in Salt Lake, so we drove all the way up and all the way back down. So that was fun. But just a fun little story. Apparently it was a collared dove, and doves and pigeons are related. But the guy that we took it to was very friendly. Just had so much to say about birds, and his knowledge was just amazing. But just I guess a short little story with not much point. Anyway, yeah, tell me, is Saturday a better day for live streams? Is Thursday good? Tell me about your schedule. What do you like? Would you prefer that I do live streams on a different weekday? And you can also leave that in the comments of this video after the live stream is done. And then for those who missed it, got a hat, Growling Pigeon hat. Oh no, you can kind of see the background through it. Oh shoot. So that's green text that says Growling Pigeon. And as far as website, that's up now. So you can go to growlingpigeon.com and you can see the games and stuff. I'll also be putting announcements, I think, and links to GitHub on here, in addition to a link to YouTube and so on. Anyway, I think that's it. Looks like Saturday is winning out, so we'll plan the next live stream for a Saturday, and it will be a month away or so. Anyway, thank you all for joining me and participating and chatting it up, and I'll see you next time. You guys have fun.